So yesterday we together we have done a classification analysis of the Nam province, if I remember exactly. And I was wondering if you have tried to do by yourself a classification. And you can share the screen. We can see together, see if you had an issue. Because for me, it was important to show you how to do it. But yeah, I would like to see if you have done something essentially. So even if you want to write in the chat, I don't know. Because at the moment I don't have any other example. We can eventually start. I can show you. Okay, looks like everybody. Okay. Yeah, if you want, you can share your screen with what you have done. But eventually, what I can do, I will share mine. So today there is, in any case, we will have a presentation later. On flooding, I think. So yeah, I will not take the whole day. Can you see my screen? Can you please confirm with the Google Earth Engine?
Yeah, I can see your screen.
Yes, I can see.
Okay, good. So just to summarize what we did yesterday. So of course, the first thing was importing the shapefile you provided me, so which is the Anam province. And then before defining this, we essentially uploaded the satellite imagery. With this function, mass2cloud is used to remove clouds based on these two bands, 10 and 11. We uploaded a mosaic of image spanning 8 months of observation from between January and August. So to have a whole coverage of the area. Then we define the different classes, which automatically Google Earth Engine brings at the top. Okay, you can see we defined, we kept at the level 1 on a very broad classification level. So as you can see, we didn't distinguish between roads or building, but just we put everything, all mining site, we put everything in artificial surfaces. Then we defined 2 different types of agricultural areas, yellow and green. Forest and wetlands. The same, we made also another distinction between water bodies. And then, we added validation side. So all this with an extension V. What we have done here is essentially creating a list with all this data in a table. So then we extracted, also selected the bands we were going to use for the classification. As I told you, spectral resolution could be important because some length cover could have the same spectral signature for some bands, but not for all. So the more the better. And then we used the classifier. In our case is CART, some machine learning tool, which created, if you remember my presentation, a tree where he essentially looked for specific value for each of the bands and then assigned to a class. And that's it. That this is our confusion matrix. If you remember, I run it now. I told you that these are just the validation side. I highlighted. So you could see 6 images. What I want to do is show you, for example, how we can eventually improve the results. So you could see, first, this is because we made a mosaic. So probably this is the edge of the 2 sentinel image. We should consider probably this province is quite big. It will be some thousand of square kilometers. So it's very unlikely it will be covered with just one image. You could see the overall accuracy is not bad, but you could see this strange artifact here with this sharp boundary. And importantly, I also suggest you to have a look to the validation error matrix. So essentially to understand what of the how the match between the map, so the classification, with the validation side. And as you can see, this Lancover class 1, which in our case correspond to agricultural areas yellow, you see Lancover 1, it's very bad. So you see only 5 of these nine sites, only 5 correspond to agricultural areas yellow. Other 4, they are classified as artificial, they correspond to artificial surface. So the first things to improve, first the validation error matrix, and consequently also the overall accuracy, is looking for, yeah, the, if you remember, now I'm just checking this. So the agricultural areas yellow, what I will do is I will untick the classification. As you can see, you cannot see because they are polygons. So this could be an issue if they are very small. Where are these polygons? You see? Yeah. So ideally, what I would suggest is essentially, yeah, let's delete this polygon and let's create instead for the training site of these agricultural areas yellow. Let's use some point. So you could see now what I'm doing is just changing the training site. There should be also other for the agricultural areas. Let's see. There should be some yellow polygon. As you can see, this is the problem where the you see the classification, the edge. You could clearly see this is due because it's the edge between 2 images. But of course, mosaicing is important because it's the only way we can work at regional scale, essentially. What I will do is, here again, I will delete this polygon. I want to show you and use some points instead. One thing you could notice here, this could be, it's likely to be, it's not a sharp boundary, so it's definitely not the edge of an image, but it could be that, I mean, it's definitely due to the mosaic. So if you remember, we mosaic every image. In our case, there are 6 images across different periods. So every time, for example, in one of these 6 images, there is cloud, it will be that part, in this case, probably this part will be replaced with another image where cloud is not occurring. So for this, you could see this strange, okay? So probably this was another time of the year where there were other conditions, whether climatic condition. So I just changed this agricultural areas error. So at the moment, I'm just focusing in improving this. So I want that there is essentially all the validation sites then fall here. There is no value outside these other classes. So now I'm running again, and I hope to improve that 82%. So let me know. I hope nobody replied on the chat, so I assume that you were able at least to produce the classification, but let me know in case. Don't be afraid or scared. I mean, we are here to learn. And also you have seen also my map was very bad. So you could see now a slightly improved, just 1%. Okay. Now I have the opposite problem. You see of these 9 sides, 5 are still okay, good. 4 are classified still as agricultural areas, but the green one, okay, Lancover class 2. And so we can still play a little bit here. But for example, you could see also there is a huge problem. I told you wetlands are a massive problem. In our case, essentially, there are no wetlands. I mean, in our case, essentially what happened is all the wetlands, we should be class 5, Okay, so 0, 1, 2, 3, 4, 5 should be here. It means that in our classified image, the validation site is one validation site correspond to land cover 1, so agricultural areas yellow, 5 to agricultural areas green. What we could do eventually, I told you I don't like wetlands, it could be very tricky to distinguish. Let's delete them. Both as a training, both as a validation. We, of course, we need to remove also from the list here. Okay. 1, 3, 4. This is so we will have 5 classes. I hope it works. So let's see what happened. I hope there is no. Okay, so there is a wetlands haven't cancelled. You see here there is an issue. So there is wetland somewhere. The best way is to look for it. Okay. So let's see if it works. So it's going. So now hopefully should be much higher. The probably will be around 90. And let's see. So the good things is we can, don't worry, this is again the error related to it cannot contain so many training and validation sites. You could see it's 86, so it's almost 87, so it's increasing, improving a lot. So you see, and the only problem we have now is still agricultural areas, but you can see most of the other, they are correctly classified. These wetlands is not presenting anymore, so don't worry. But yeah, if you have a closer look, for example, you can investigate and you could see, for example, any things you don't like. It looks like water. It's perfectly classified. You could see here, this is the background map. And so, yeah, it's an iterative process in the end. The good things is, yeah, once you define, probably the most time consuming part, you see this is the DAM, is the selection of training and validation site. But once you have done, you can easily move them, you see, shift around and doing things like this. And yeah, I think for me it's everything, because yeah, this is in the end, for example, if you want to use other classification, for example, random forest, usually should be quite easy. You could say I'm looking at random forest. You can see these are all the supervisor classification I showed you before. Cart is the one we use, and again, you see, you simply can copy and place there. The important things is essentially you have already defined your land cover. Then changing between different training classifier, it's easy. Also, for example, this I think is the spectral value mapper. Probably this is support vector massing. Sorry. So it's easy. Once we define these classes, we can essentially change our classifier. So for me, yeah, it's everything. I don't know if we want to go straight. I mean, we can have now a discussion on your experience if you had issue. But otherwise, we can move, Roshan. I don't know if you agree on the presentation floating, because if there is nothing people want to, yeah, if you are happy.
I think there was a question, I think.
I need to check. Sorry, I need to stop sharing because otherwise I cannot see. One second. Oh, we probably want simple translate. So Andrea, I think about your question, how the polygon simple site translate to value in the confusion matrix. I think they consider the whole all the pixel in that polygon, so all the point within that. At the moment, I don't think we have. You could see for the validation, we have just all of these elements. They are essentially points. So
Can I elaborate on my question?
yeah, sure.
So I saw that one of your samples, it had, for example, 4 elements. So they could be 4 elements made out of points, or there could be
Yeah.
a polygon in there. So how does that 4 translate to the confusion matrix specific to its role? Because, for example, I saw that you had a land cover class with 4 elements, but then when I look at the corresponding confusion matrix, it has values of, say, 4 and 5. So the total value of 4 and 5 would be 9. So they don't correspond to the number of elements in.
It's because, for example, if there is a polygon, I think what it does is essentially taking the pixels, so the element within the polygon. So let's say there is a polygon of 3 pixels, it considers 3 points, 3 pixels for that polygon. I mean, we can easily check now, essentially what I can do.
But theoretically, if they were all points, if you just use points, they would all add up to the specific row. Okay.
So I think what it does, we can verify essentially by canceling all the, for example, using just a polygon for one of these validation and see what happened. But yeah, in any case, it's pixel based. It should be when it does the confusion matrix. Because yeah, you do essentially a pixel by pixel analysis comparison. Even if it's a polygon, you consider all the pixel in that polygon. But we can see. So for example, these agricultural areas green, you could see here. We have just 2 polygons, Angelo. So you see what I will do. I will delete this. Let's see now how many.
Oh, sorry, I can't see your screen.
Oh, sorry. Yeah, because when I see the chart, I don't know why I cannot. So what I've done, you see now, agricultural areas green is just 1 polygon. So it should now essentially taking all the pixels within that polygon and consider those as single elements for the confusion matrix. So let's see. Okay, don't worry about this. This is just a warning. If you have a big error, you will not see the results. Of course, to be honest, I think we should have selected much more training site. But of course, this is just a constraint based on time available we have. If you see our agricultural areas green, it's land cover number 2. So yeah, I think, can you see, Angelo? So essentially, I think it took the 12, you see there are 12 elements. So essentially, these are the 12 pixel inside this green polygon. We use it for, where it is? It's better probably to use this. But now I cannot find it. But essentially, you see, we use it. You see, agricultural area screen is 1 polygon made of 9 pixels. Yeah, this one.
It doesn't seem to correspond. Artificial surfaces are the first row, right? The one with 0.
Yeah.
Yes. It says it has 9 elements, but it only has 3 there.
No, this 9 is the training. 3 is the validation. It's here. So you look here, the validation versus the classification.
Validation 3 elements.
So this one. because of course the confusion matrix is, so he's not looking here at the training site at these 9 elements, but he's looking at
Okay, that makes so much more sense. Thank you.
this. So these are, sorry, so probably my bad. So this is the classified map. So this is 0 in the classified map, 1 in the classified map. These are the number of validation sites. So forget about this first. It's all about, yeah, the last here. So you could see this agricultural area screen, number 2, which is, you see Lancover 2. He essentially, what's this doing? It's one element. So it's this, where is this polygon? I always forget where it is. But anyway, for example, even this is a polygon, it takes all the pixels. So for him, there are 12 points to do the analysis. These are 3 because they are just 3 points. That's it. So I hope this makes sense. So for example, even these water bodies, you see there are 3 elements, but probably they are, yeah, 3 polygons. So in the end, they are 22 points. So I hope
Thank you.
Okay. But to be honest, I mean, yeah, I think for the training, probably it's better using Polygon. For the validation, using Polygon, of course, is a gamble because it means we can be, let's say, naughty. And what people do, I can show you. For example, we can also get a 100% better classification by doing this. Essentially what they do, people, when they work on papers, just to show how beautiful is our results, what they do is, for example, they move the validation site here to match with the Lancover. So you see, these are only my validation site. What they do, you see, this is agricultural areas, validation site. It's taking a while, sorry. But it's been classified as urban area. So what they do is simply doing this. They move, okay? So to match with, yeah, with other classes. So now if I, for example, run again, I should have a much better, with 90% validation. But of course, the best way is to keep independence and define before the validation site. So I think, just to show, let's see how better become the classification. So now what I've done is essentially I didn't change any training site, but just the validation. And yeah, it should be much better. You see 91%. Just because, yeah, so you can play with this. So I will stop sharing just to see. Yeah, so there is Yufan. Yeah, she wants to share the screen. So please do it. Yeah.
Thanks. Okay, so I want to share my results with you guys. Are you guys seeing my screen?
Yeah.
Okay, so let me introduce myself. My name is Hiếu, and I'm from the female lab in the National University of in Hanoi, in Vietnam. So, and for this assignment, I chose Ninh Bình province.
Okay.
And what I did was I did as as you said, I divided the classes into some subclasses, and so at first I had a total of 7 classes like yours, but when I run the model, I realized that the model can easily mistake some of the classes with each other. and the overall results was kind of bad. You know, it only achieved 0.14
accuracy.
And so I decided to like not to divide the classes into subclasses, and then I ended up with only 5 classes. So here they are, and the overall results is over here. You know, but I seem to have this one issue where I might have defined a whole lot of samples for the forest class, and so my question was initially like that of Angelo's, and you know I defined the samples for the forest class as 3 points and 3 polygons. Yeah, but the polygons were a little bit too big, and so I think that just ended up with a lot of samples, and you know, in the end, the result was, you know, heavily weighted on the forest class. And personally, I think that the final result wouldn't have been as good as this, you know, if I had less samples in the validation.
So, sorry, can I interrupt you? Yeah, I think definitely you have to do balanced way.
Yeah.
Because it's too biased by the forest. So it's still good. I mean, the accuracy, if you look at the number, is great. But you could see if you are having a general look, you have a lot of clouds, for example. You could see that are
most of the things up here, you know,
so
are clouds.
Be careful. Always try to balance. Of course, it's a balance also related to how extended are. Probably forest is in any case the most extended area, not land cover here. But still, it's to I think probably more than half of the validation site are forest. So, mathematically, your classification is great. But then, if you see, so I think the first things I will change with you is we'll check the cloud filtering. If you remember, we used 3 filters at the beginning, okay? And then can you remove? There is something strange on. If you can remove, there is like black window.
That's the camera window.
Okay, now I can. So if you go down, you should be able to see after image collection Copernicus, after line below line 18. There should be also cloud percentage. To be honest, it's very bad. Even with 5, try with 1. Try to reduce to 1, and so we will take.
If I reduce it to 1, it would only result in 1 picture, and I don't think that the result would, you know, increase any better.
So what I will do is, to be honest, but let's see now. Is that snow?
You see the clouds are still there.
Snow clouds there. I know, probably not in Vietnam. But no, I will. To be honest, there are. Or what you can do is you can add another class for clouds and classify those, because otherwise they will definitely be merged with artificial surface.
Okay, but see, looking at these samples, you know, of the artificial class, you know, let me just zoom in.
Yeah.
You can still see, you can see that there are some samples that I'm afraid that has, you know, the colors that it's a little bit, you know, similar to the cloud. So do you think
no, for this. So I will try in any case to define clouds as a class of its own and see if it's able to distinguish. I mean, the best solution would be to choose another year if you can, and because this cloud, it's very bad.
Okay.
Also because it could affect easily. But eventually, if you are limited to 2020, you have you need to a 2020 map. We'll define clouds and see because for sure will at least most of the clouds will be mapped as clouds.
Yeah.
So at least because otherwise you see you have a lot of artificial surface.
Yes, and another issue that concerning the mosaic of the images.
Yeah.
Do you have any methods that can minimize that effect? Because some images can have different range of colors, or some effects that the clouds that made it to it. For example, this. Why is it? Oh yeah. Just wait for the whole image to load. What I'm trying to say is, between the two images, one image being, covered with the certain amount of clouds, it kind of like created this hazy effect. It makes everything looks kind of bluish, and it could.
Yeah. The only things it could be you can work for small area eventually. So for example, you can, I mean, when you select, you can work just on the right eastern side in this case. So you can do a different type of clip. Or because this halo effect, this haze effect will you cannot remove it. And this is even if you use any other platform, this is part of the image.
Yeah, so there's nothing we could do about it.
So I mean, the easiest things would be just choose a different tier, because if you can, of course. I don't know if you are, for example, interested. I don't know. I mean, Angelo suggests, there could be a surface reflectance. I don't know, but for sure, so far we are uploading the. This is the top of atmosphere. So yeah, we could try to upload the surface reflectance. I don't know if sometimes surface reflectance, since the archive is not full as the top of atmosphere, but we can try. So yeah, if you can try to add, I don't know if it's easy, but let's try line 18. You see, you can add S2 underscore SR, here.
SR?
Yeah, surface reflectance. I don't know if it's work, I hope.
Okay, running.
Good. So these could...
Oh yeah, the haze effect is gone.
Okay, good.
Yeah, but I have to increase the cloud percentage because...
otherwise you have a whole...
Yeah, so that is basically my work.
Thanks, Angelo. So, good. So it means that, you are... So, but that clouds, you could never remove them. The only thing is, you can define the class for clouds. That's it.
Yeah, thanks.
And so anybody else? I mean, please share. You see this issue. These are things that we can together resolve.
Thanks for your sharing your screen.
Angelo, if you want to share, your screen now, please do it. Don't worry. I think it's important now we interact and see, where we are. As you could see, it's you can find a lot of things online. I just give you like the basic, but there is a lot of things we can do. I don't know. We can still don't see. Okay, now we can see. Yeah.
So it's a much smaller image. But I created a bounding box around a city. So it was easier because there's a lot of contention in terms of city boundaries. So I just used the bounding box instead. So hello, sorry.
Yeah.
Okay. So I used the same thing in getting the image. I still used Sentinel-2. I didn't use surface reflectance. So I also added false color image. So it might be easier to look for, say, vegetation or differentiate between, artificial surfaces and vegetation areas. So you can use that to better pinpoint.
Mm-hmm.
I use
Nice.
my points basically. So I add them into.
Angelo? Hello? I
Can
think
you
we
hear me?
lost.
Oh no.
Can you repeat? Because I think we lost
Oh.
you. Who?
I also added an NDVI index, so
Okay.
it'll there are a lot of indices that you can use, but depending on your objective, I guess you can use modified normalized built-up index and water indices to better delineate your classes. And um, I I know that you can also use indices as bands, in that you can add indices, different indices as bands, and then use them as variables as well. So yesterday we just used the bands set already in the Sentinel image, but
Yeah.
you can add whatever else that you need. So there. For for this for this I use random forest. I have a question as well because it says that if I look through, like, say, cart, it's red and it says deprecated. So maybe they changed it. It says to use smile cart instead. So maybe the original classifier.cart is not updated anymore.
It could be, yeah. It could be.
Yeah, so because I remember using cart last year and it wasn't italicized and in red.
Okay.
So there. And I also included the validation, overall accuracy, and then kappa values. They're usually what you use for
Yeah.
accuracy. So they're, I guess, easy to you just put print and then put the name and then the variable and then determine if it's accuracy, if it's kappa, consumer accuracy, and producer's accuracy. You can see a lot of what the scripts are in the docs. So you can just search whatever and you can find whatever you need, I guess. So
Yeah.
so there. That's all.
Yeah, I think thanks, because yeah, it looks very nice. So yeah. And good. So has anybody else want to share how his experience? We still have, I think, I don't know, Roshan, but probably at 10 we have the presentation of Tan. Is Tan presenting or?
Yeah, I think Tan is presenting.
Yeah, we can have, yeah, if you have want to share, yeah, your experience. Otherwise, probably we can have a break and then, yeah, go with the presentation. But
Yeah, should we take about 5 minutes or 10 minutes break, and then we should Teng, you okay doing a presentation for about 20-30 minutes?
Yes, it's okay for me.
Thanks.
okay, good. Okay, and of course, linking to Tan presentation, just of course, you can also do an analysis of radar data in Google Earth Engine, which could be very useful because radar data tends to be 4 times in Sentinel-1 compared to Sentinel-2. It's 4 times larger in terms of size. Usually, we're talking an image of 4 GB at least. So it's useful having access to online archive instead of downloading. Yeah, okay, so I'll see you in 10 minutes.
Is that right, 10 minutes or shorter?
Oh,
No.
We can, yeah, Angelo want to show, yeah, let's do, we still have, yeah.
Yeah, we've got lots of time today.
Okay. Later or now?
Can you share again, Angelo?
Okay. So screen sharing. Can you see? Hello?
Not yet, but it's uploading.
So,
Yeah.
okay. So we did this. We merged the points. So I did just 4. And then we did this as well. I used the same script. And this is the different script that I used. So it supposedly adds it randomizes things, and I added a variable that represents the amount of split that I want. And this is the other variables that kind of quantize how much training you're going to part.
Okay.
So this is filter less than. So since split is defined as 0.7, so it's less than 0.7. This is the training set. And the testing or validation set is greater than or equal to 0.7. So in that way, you don't have to create 2 sets of samples for, say, water bodies for training and validation. So you can automatically split them, and it will be so much easier.
Yeah,
So
indeed.
there.
Yeah, if you can share, yeah, this code with us, yeah, would be great.
Sure. How would I share it? Should I just share it?
I think no, it's better you copy everything. And then yeah, you can send an email. I think the best way, and we can put in the Google Earth in the Google folder. We already uploaded everything. So if you copy even on a text file, Notepad.
Okay. So there.
Thanks.
So it's a much easier way.
Yeah, that
You could
is.
send me a text file to me, and I will upload to the Google Drive, shared drive.
Okay, sure. Thank you.
Yeah, this, to be honest, Angela, is very good because this will reduce also any bias from the user perspective. So
Yes, that's the one important point that I wanted to.
Because as you can see, with this machine learning, essentially, apart from training and validate, it's supervised. So apart from this, there is no much we can do. We can change some parameters, number of interaction and everything. Apart from, so it's important we have a, let's say, objective way to define this side. So I think we can have a break of 15 minutes. Let's do
15.
just so we can start at almost 10
Yeah.
3 p.m. and 4
Yeah.
p.m. So it's okay.
Is it okay, guys?
Yeah.
Okay. 15 minutes.
Good. So we'll stop recording and